Hey guys, today we are talking about radians. This animation that's going on right now is what we did in class with the pipe cleaners, hopefully did. So you see you have that unit circle with the radius of r, and now we're taking that radius, making it the arc length, and drawing that angle in. And that's kind of exactly what a radian is. It's just one section of your circle that measures that has the arc length of the radius. Okay, so again, that's kind of what we did in class. Just take a look, watch that video GIF thing. Write down your essential question. It's going to be, how do I graph angles given in radians? I believe that's over now. Okay. Okay, so the first thing we need to talk about with radians is coterminal angles. So when you're thinking about the coterminal angles, remember all that means is that they end at the same place. They share that terminal side. They share the ending side. So before, when I had coterminal angles, remember I used to add or subtract 360 degrees. Well, now I have to go and think about that in terms of radians, and that's when we use that pi. So this is a radian measure. This doesn't always have a pi in it. Sometimes you can have just regular numbers, but if it has a pi, that kind of lets you know for sure it's a radian. So if you remember on that drawing that we did, or the GIF that we saw in the beginning, your circle now goes halfway around is pi, and all the way around is 2 pi. So instead of adding or subtracting 360, now we're going to do plus or minus 2 pi to any of your angles if you're looking for coterminals. Okay, so if I took my angle measure of pi over 6 and I added 2 pi to it, that would get me a coterminal angle. However, because we're dealing with fractions, you've got to find that common denominator before you can add these two things together. So really, working in radians is knowing how to do fractions. So when you look in here, if I wanted a common denominator here, my common denominator would be 6. Remember, then you have to multiply both the top and the bottom by 6, so this will turn into 12. So when I add pi over 6 plus 12 pi over 6, I get 13 pi over 6. So that's an angle that is coterminal to pi over 6. Okay, we can do it the other way too. If you took pi over 6 and you subtracted 2 pi, which remember we just said was 12 pi over 6 because we found a common denominator, and that would get me the coterminal angle of negative 11 pi over 6. Okay, so again, if you can work with fractions, then these are going to be pretty straightforward. Otherwise, you're going to have to remember all those rules about common denominators, etc. if you want to add or subtract. Okay, so that's how you find a coterminal angle of something in radians. Now we want to know, well, what if they gave me a radian measure and I wanted the equivalent degree measurement, or vice versa? So when you are converting degrees to radians, remember on that circle that we had that 360 degrees equaled to 2 pi radians, which would mean that half of that would be 180 degrees would be equal to pi radians. So we're going to use that fact when we're trying to convert things between both of these measurements. So if I started with 1 degree, okay, 1 degree, if I took this up here, if I had, well, let me move it. Maybe I can move it. Well, I moved the whole thing. So if I had 180 degrees equal to pi, and I wanted to get this to be 1 degree, I would take both of my sides and divide by 180. So I know that 1 degree would be pi over 180 radians. So if I'm trying to convert here, I'll take my degree measurement and times it by pi over 180 degrees. So for instance, if I wanted to convert 90 degrees into radians, what I would do is I would take 90, the degree measurement, times pi over 180. It's kind of like the mole conversions, dimensional analysis from chemistry. Okay, and then you could just simplify this down. This would divide into this guy, and you would get pi over 2. So equivalent radian measurement would be pi over 2. Okay, so again, if you're trying to convert between these two, you're going to take your degree measurement and then times it by pi over 180. Similarly, if you're trying to take a radian measurement, which you see is usually going to have a pi in it, we're going to have to get that into degrees. So if I take that initial fact that we talked about before, that pi radians equals 180 degrees, and I want to find out what 1 radian is. So if I take this side and divide it by pi, and divide both sides by pi, I'm going to get that 1 radian is approximately 180 divided by pi. And if you were wondering when we were doing the pipe cleaner thing in class, that means if you threw that in your calculator that 1 radian is about 57.296 degrees. Don't have to memorize that. That's just kind of funny because we said it was a little bit less than 60, and there you go. Okay, so same thing. If I'm trying to take my radian measurement and I want to make it into a degrees, so for example, if I took pi over 6, the one we were dealing with before, and I want to make that into a degree measurement so I could figure out what that was, where it was on my coordinate plane, I'm going to take the radian measurement and I'm going to multiply it by 180 over pi, because that's how many degrees are in 1 radian. Okay, so right here we're going to take pi over 6 times it by 180 over pi. Your pi's should cancel. That's the whole point. You don't really want pi's in your degree measurement. 6 goes into 180 30 times, so that would be 30 degrees. Okay, and I know it can be kind of tricky going back and forth from degrees to radians. What you're thinking of is you're trying to figure out, do I need to add pi or do I need to cancel out a pi? So if you're trying to get a pi in here and make your radian measurement, you're going to put pi on the top. Okay, so if pi is on the top, it's going to leave a pi in your answer. If you're trying to go from radians to degrees, so you're trying to get rid of your pi, then you want pi to be in the bottom so it cancels out and it just gets you a number, which would be your degree measurement. Okay, so we are going to use these facts in order to make our unit circle. So grab that unit circle that I hopefully gave you yesterday. You can either glue it in your notebook or just write on it and glue it later. So this is what we call the unit circle. The reason we call it a unit circle is because we're just calling this a circle that has the radius of 1. So this length right here, or any of the lengths along from the center out to the end of the circle, are going to be length 1. Okay, so the first one we're going to start with are the ones that we kind of already have seen. So I'm going to make this guy blue. And we're going to talk about those border angles. So right here, this guy, we're still going to call this 0 degrees, and it'll also be 0 in radians. Okay, and then halfway around is going to give me pi radians. And then if you go all the way around one more time, that will be 2 pi radians. Okay, so that's like the middle. Now if I wanted to name these angles that are on the vertical axis, you're just thinking about, well, what's halfway between 0 and pi? Well, half of pi, or 0.5 of pi. Now the one thing we're going to be dealing with a lot here are going to be the improper fractions. So we're going to try to leave things as improper fractions just so we keep values exact. Okay, because if we had like 1/3 pi, that would be 0.3333, and we wouldn't get the exact answer. So we're just going to leave this as pi over 2. So that angle up at the top is pi over 2. Same deal down here. In between pi and 2 pi is going to be 1.5 pi, or if we leave that as an improper fraction, 3 pi, sorry, I lost that, 3 pi over 2, or 3/2 pi. Okay, so those are your border angles. We're going to keep going around in this inside here. I'm going to use red. Let's see if I can get it. Good, I got it. And we're going to continue kind of doing this half business. So on my red angles, if I think about what's in the middle of 0 and 1/2, or 0 and pi over 2, that's a 1/4. So that would be pi over 4. Okay, then I keep going around, and this would be, so we have in between a half and a whole would be 3/4, so 3 pi over 4. And we can continue doing that. Now the one cool thing when you're thinking here is if you had numbered these in terms of pi over 4, remember this guy would be 2 pi over 4. That would be an equivalent fraction. So I would have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which would make this red angle 5 pi over 4. This guy's 6 pi over 4. And then right over here, 7 pi over 4. And then 2 pi would be equivalent to 8 pi over 4. Okay, so that's one way you can think about it when we're going around and numbering. If you think about just numbering in terms of the one denominator value, it can help out a lot. Okay, so those are kind of like the half angles. Now I'm going to go ahead and tell you, and we calculated this before. I'm going to go ahead and do this one in a different color. Let's do green. Okay, and so on this one, the green one, we calculated this before. This first degree, it looks about to be 30 degrees. It is. And we calculated before when we converted between degrees and radians that that's pi over 6. Okay, so pi over 6. I can do the same thing if I divide this into little sections. And I'm going to go ahead and I'm going to make one more set of lines. Hope you have all the colors tonight, guys. And we're going to think about this. I would love to delete this little thing. Okay. And then we're going to think about this in terms of pi over 6s. Because if you look here from the purple to, from the green to the purple, you're just going about the same angle measure. And I know it's kind of hard to see on this guy. I'll show you a better picture in a little bit. But you're really going pi over 6. So if this is 0, this is pi over 6. This would be 2 pi over 6. 3 pi over 6, right, because that would reduce. This will be 4 pi over 6, 5 pi over 6. We're skipping the red because that's not in my little 30 degrees every once in a while. Then we have 6 pi over 6, 7 pi over 6, 8 pi over 6, skipping the red. Then we have, this would be 9 pi over 6, 10 pi over 6, skip the red, and 11 pi over 6. And then I guess if you wanted to keep going, this guy would be 12 pi over 6. Okay, so that's all my angle measures for those pi over 6s. Now you're going to notice that some of these would reduce down. So for instance, when I got up here, this is 2 pi over 6, which would be pi over 3. Okay, so that's the other denominator that you're going to see a lot of. You're going to see a lot of pi over 3s. Okay, 4 pi over 6 is the same thing as 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6 we already said was just equal to pi. 7 pi over 6 doesn't reduce. 8 pi over 6 is going to reduce to 4 pi over 3. 9 pi over 6 would reduce down to 3 pi over 2. 10 pi over 6 would reduce down to, 5 pi over 3. And then 11 pi over 6 doesn't reduce anymore. Okay, so this is your unit circle. Basically, if you go around, you can count by just those denominator values. So if you notice here, with the purple ones, we went pi over 3, 2 pi over 3. This would be 3 pi over 3, the pi angle. 4 pi over 3, 5 pi over 3, and then 6 pi over 3, which reduces to 2 pi. Okay, so that is your unit circle. Now if you went back through and you wanted to put in your degree measurements, which is perfectly legitimate, like if you were to go through and convert all these, this would be 0 degrees. We already said this one was 30 degrees. This guy is 45 degrees, which makes sense. It looks like it makes that half angle. It's halfway in between 0 and 90. This one would be 60 degrees. This one right here is 90 degrees. It goes straight up and down, makes that right angle at your coordinates. This one is 120. This guy, the red ones are adding 45 each time. This one added 30 from the 120. Remember, this one we said was 180 degrees, halfway around. Then we have 210 degrees, 225, again, this is just adding a 45, 240, 270, because that's almost all the way around, and then 300 degrees, 315, I added 245s to that one, and then 330 degrees. Okay, and if you notice here, if you're looking in that first quadrant, you're going to see those angles are ones we've seen very recently, 30, 60, and then 45, 45. We're going to see some triangles in a little bit. Okay, so that's basically your unit circle. We're going to get a lot of practice labeling your unit circle, memorizing which ones go where. And you're always welcome to convert to degree measurement for a little bit in order to figure out, exactly where those angles are. Okay, we're going to go back and talk about things that are graphing not on this unit circle. So things that don't have a denominator of 6, 4, 3, or 2, I guess. Okay? So we're graphing angles that are not on the unit circle. For instance, 2 pi over 7. Now, like I said before, you can convert this to degrees. However, your quiz on Friday is not going to have calculators, so that's not going to be very pretty. And also, you're going to find out it's not quite as easy as going ahead and doing what we're about to do. Okay? So we're going to graph these angles. We're going to graph 2 pi over 7. So I'm going to go ahead and draw my coordinate grid. Wow, that was so not straight. And then I'm going to label the things I know. I know those border angles. So I know that that's 0. I know this is pi over 2. I know this is pi. I know this is 3 pi over 2. Or 0, 90, 180, 270. Okay? Now what you're going to do is think about common denominators. Because if I relabeled this is 0 pi over 7, this guy would be 7 pi over 7. So going that whole distance, well, half the distance over there would be 7 pi over 7. So now you ask yourself, is the number that's in your numerator, is that closer to 0 or is it closer to 7? Well, 2 is closer to 0 than it is to 7, so my angle is going to fall in quadrant 1. Okay? And you can think about this too, if you were thinking in terms of pi over 7, this would be 3.5 pi over 7, and 2 would fall in between 0 and 3.5. Okay, let's try that again with 15 pi over 8, negative as well. So I'm going to draw my coordinate plane. Again, I know this one's 0, I know this one's pi, and I'm going to go ahead and put this in terms of pi over 8. So over 8, this guy would be, remember we're going in the negative direction because there's a negative sign, so this guy would be negative 8 pi over 8 to get over to that side. So my number is bigger than that. I have negative 15 pi. So then I'm just going to keep going, and if I go back around, this will be negative 16 pi over 8. So I think about, is my number closer to negative 8 or negative 16? Well, negative 15 is a lot closer to negative 16, so this one is again in quadrant 1. And remember though, when we draw this angle, we're going to draw it going backwards like this because we went the negative direction. So this would be an approximation of negative 15 pi over 8. Okay, last but not least, we have 18 pi over 7. Now the first thing that you might have noticed is this value is greater than 2 pi. Okay, 2 pi of this one would be 14 pi over 7. So this guy is bigger than that. That means it's making a complete rotation around your axis. So you're going to have to find the coterminal angle before you can graph. So the easiest way to find your coterminal angle is just to add or subtract 2 pi. So when I look here, I'm going to subtract it because this number is bigger than 2 pi. So 18 pi over 7 minus, remember we need a common denominator, so 7. So 14 pi over 7, a coterminal angle to this guy would be 4 pi over 7. So when I'm graphing, I'm going to be graphing 4 pi over 7 and then just going around an extra rotation. Okay, same deal that we did in the other ones. This one's 0. I'm going in the positive direction, so this guy is going to be 7 pi over 7. Find that common denominator. And since I'm looking at 4 pi over 7, you're going to ask yourself, are you closer to 0 or 7? I'm actually closer to 7, and if it helps you to see, remember this one's 3 pi over 7. So this guy is a little bit over here. But remember that you went all the way around once and then right here. Okay? So that's all I got for you tonight. Again, when you are looking at that unit circle, this kind of is helpful. If you go through and you label all your things with that one denominator. So for instance, this is over 2 over 2. Wow, this is going really fast. When you look at that, if you're just checking and you label it with that common denominator all the way around and then just try to reduce from there, that can help you get a lot of those values in there. Okay? If you have any questions, I will have tutoring in the morning, and I hope you have a great night. Remember, fractions, fractions, fractions.